Hey, this is Mr. Coker with Geometry Preview 3, External Angle Theorem. So from Algebra 1 class, this is the third video dealing with something that you'll see next year in geometry. I do have another video about this, but this is one again for Algebra 1 students. For my Algebra 1 students, or anyone who happens to see it. So, external angle theorem, what this is saying is, and the reason I wanted to I started with looking at just a triangle that we have. That was the angle sum theorem. Triangle equals 180 degrees total. So in this triangle, remember I'm ignoring what's outside the triangle. We have 60, 60, and 60. That adds 60 plus 60 plus 60 is 180. So that should make sense. Now ignore these two. Let's look at just this line and this line. The last video talked about consecutive or supplementary angles as well as vertical angles. Now we don't have vertical angle here, but we do have consecutive angles, which are supplementary angles that also equal 180 degrees. So here we have 120 and we have 60. Well, what's 120 plus 60? It's 180. So we're combining the last two things that we did into something that involves both of the last two things that we did, and now I put them together. And it's called external angle theorem. So the simplest way to think of external angle theorem is this, whatever's outside the angle that's right outside the triangle equals these two angles. So 120 equals 60 plus 60. Well, what's 60 plus 60? Well, it's 120, so that makes sense. So this angle should equal the sum of these two. That by itself hopefully makes perfect sense. If it doesn't, hopefully you can just remember this rule. Now, I'm going to do one problem, and only one, where we're going to, instead of, first of all, instead of just being given this, we're going to solve for an x value. Now I'm going to erase this one. I'm just going to keep these. I'll erase them and write new values in, okay? Let's pretend that it's not, instead of being a equilateral triangle, we'll make it something different. We'll pretend that the numbers are different. Out here, I'm going to put 110 plus x, and then I'm going to do a 30 and a 70. Now, of course, don't worry about the shape of the triangle. I'm not worried about that. Let's just pretend that we adjust the angle, we adjust the shape of the triangle, and this is what we have. So now we have a degree, 30 degrees, 70 degrees, and 110 plus x. What we're going to do is this will go on one side of an equal sign. So this goes on one side of the equal sign, and it equals 30 plus 70. This should be very simple. We combine like terms, and we have 100 equals 110 plus x. I put that there too. I'll just erase that. I wanted to look like I'm dividing. I was marking those as like terms. So 30 plus 70 equals 100, and 100 equals 110 plus x. One step equation now, minus 110 on both sides, and we get x equals negative 10. Hopefully you can see that on the board, on the screen. I think you can, but of course I don't know for sure. But anyway, x equals negative 10 is what it says here, in case it is too low. But and that's it. But I'm going to now. I'll keep this up just for a second. Pause it if you need to. What I want to do is also look at. Well, actually, I'll leave this up right here, and I'll change the problem a little bit and put it up here. Okay. Let's assume that this said 2x. I'm going to put a 2 in front of x. This is something else I know sometimes students have trouble when you make a few changes, when you add a coefficient to x. It's pretty much the same thing. You set it up the same way. Sorry about that. You set it up the same way. And you see now, but instead of a one-step equation, now it's two-step. Now instead of x equals negative 10, we have 2x equals negative 10. The only difference now, it's a two-step equation, so we have 2 times x, but it's the opposite of multiplication. Division, we divide each side by 2. Here we would get x equals negative 5. I'm going to box that in. So, anyway, that's really all there is to it. You could see this set up in different ways, like you could have a variable over here. It doesn't really matter, and keep that in mind. It's not a big deal. What is a big deal is, and you could see one where they give you a number here and not here, just to try to fool you. But if they do, not a big deal. They could give you like a number here and here, and just try to complicate it. But it's essentially the same. It's always the same thing. Use what you know, which is they're 180 degrees inside a triangle. These two angles equal 180 degrees. Therefore, whatever's outside the triangle, the external angle, equals the sum of the other two angles. Keep that in mind. And this external angle theorem that looks complicated is actually not that complicated. Thanks for watching and have a good day.